Hello and welcome. I'm Bill Wake. We're here working on a basic game. Basically, it's a 1980s basic game. We've done a lot of restructuring, so we got rid of all the go-tos, and now we have a at least moderately structured program, and we're going to see if we can do some more refactoring. I think first I want to do some work on the I/O. The button clicking's a little annoying. It wasn't really exactly how the original worked, and we'll see where we go. And then I don't know. I think there's kind of a medium-sized tear apart the loops kind of refactoring. We might take a go at that. Right. Oh, let me. Okay, quickly. So the game, you're sliding the ship horizontally. You're trying to avoid the stars that roll in from the bottom. So not much to it. And here's the original code. This is very old school basic. It was from an OSI, Ohio Scientific. I don't know the model number or anything, but 4K of RAM, 4K of character ROM, 8K basic. This is not a very big system. And we've got this is the photocopy of the original listing. So you can see lots of pokes, some for loops. The arrows or the lines on the side are kind of showing where things bounce around to. So there's a bit of go-to in and out of things. And a subroutine down there. Peeks and pokes, those in 2010 or so they're trying to read the keyboard directly. There's no USB in those days. And we've done a fair bit of work. So let's go over to the IDE. All right, I just ran the tests. Everything's green. The tests are more of the basic implementation than they are of the application. So green test is kind of not super relevant to what we're doing, but let me run it. Take a moment to get that started. I think what I want to do is look at the way the buttons work now. They're simulating the keyboard. So I don't think it's a great simulation in a way, but okay. So if I hit a button and I took my hands off, it just stays hitting that button until I hit a straight button. Let's see if I can do this again. Okay, so I'm going to go right and then straight. Okay, so it's not while I'm holding it, it's once I click it, it just goes. And what I'd like to do is when I press down, I would like to move left. See, it's not even moving even though I'm pressed. And when I release, I'd like it to act like it's going straight again. All right, and let's see. Let's see where this is. All right, so Swarm is our translation of the basic code. And we've got our stuff up here. So we've renamed variables. SC is now score, and NA or LA or something is level, and so on. But the main loop is it figures out, well, it pokes a little bit of stuff that I think we've decided is not really relevant on our screen. And then it runs through a for loop trying to print these rows of stars. And in here about 79, that's where it actually pokes the stars in place. You can see the random number generator there. And then we try and handle the move. And we decide if it's safe, if the ship is going to occupy a space character, then there's no problem, and we can poke the ship in there. Otherwise, we've lost. We're going to break out of the main loop and do this. I think that break is a bit awkward. I think we can rework around that, but we'll see. All right, and then print a bunch of stuff and reset or whatever. Down here, handle move. 530 is it's a basic control handler flag. So if you turn it to 0, it turns on the basic checking for control C so it can break your program. If you turn it on 1, you're turning that thing off and you're just using pure access to the keyboard yourself. So you poke something in this particular address, that goes out to the keyboard matrix, turns on, in this case, all the lines. And then you do a peek to find, or all the rows, I should say. You do a peek and it tells you which columns are active. So I think this one corresponds to B and this one to N is my reading of it. All right. And so if you get a B, shift left. If you get an N, shift, the ship moves right. Okay, now let's see how we implement that. And we're gonna have to look at the peek and poke. Okay, so our peek, let's see, well, start with poke. Our poke checks if you're in the range of the screen because it's a memory mapped screen. And if you set it to, if you poke 57088, it stores that value that you poked. Okay, so that's the list of rows in the keyboard matrix. All right, so just imagine your keyboard there. You got a bunch of rows, you got a bunch of columns, and imagine the keyboard's a switch that connects a row to a column. So you can decide if it's on or off based on whether the key is pressed. Okay, and the peek. So similarly, it looks in the screen range, but if it's 57088, that magic number for the keyboard matrix, it says, well, if you have poked a value, and we have that row lit up, a simulated row, then return the column. Okay, and so keyboard simulated row and keyboard simulated column, let's go find those two. All right, they're up here. Let's see. And let me get to the content view. Okay, so here, well, this is us simulating the basic output. Okay, so we have 24 rows and columns of output. All right, and here we can see we've done this. We've got the button says keyboard simulated is row 4 column 8 or row 0 column 0, meaning nothing's on, or it's row 4 column 16. So I'm not sure if the logic may be backwards from what I expected, but at any rate, we set rows and columns when you click the button. So clicking down on it sets it to those simulated columns. Whenever it goes to look at it, code's shaping up. Yeah, it definitely has improved a lot. Anyway, you go to look, when it polls, basically that handler subroutine is polling, goes out to the keyboard and says, well, are you held down now? And you still are, because once you hit this, then the simulated thing is in place. But hitting this, it's, if you think of a button tap in iOS, you press, it doesn't do anything until you let go and your finger's on the button. If you press on a button and you slide your finger off and then let go, it doesn't trigger. All right. I don't care too much about that. I just want to make it so that when I click on, well, I would like it to be when I press on, it starts working. And when I lift off, it stops. Whether I lift off on or I, move off and lift off. And so I want to change this. This part is all just how I decided to implement things. It is simulating the keyboard. All right, but what I don't know, long story short, supposedly, I don't know how you normally access those. This is the action that you get when you release in the normal way. Okay, you click on the button, you let go of the button without moving off it. All right, and when that happens, you execute this block. There must be a block that's like, what do you do when they move on or move off or something like that. So let's see what we can find. Probably should. Oh, interesting, but not relevant to us. Okay. All right. Yeah. So creating a button, various constructors, but they have an action and they have a label. Or you can use a string and a action. Okay. And maybe this is view modifiers. Well, I don't think it's accessibility. Foreground color, no. Control. A badge you can put on, that's built in now. A lot of stuff here. Interactivity disabled. Swipe, no. On hover, that's not really a thing you can do on iOS. Focus. Digital crown rotation. I have no idea what that is. Well, wow, I can't believe how many of these there are. But none of them sound like what I want. Ugh. Deprecated. Okay, let's try a different search. Swift UI, detect, button, enter. Touchdown, that's kind of what I want. Oh. All right, so apparently we can add a gesture, drag gesture, on changed, on ended. All right, let's give that a shot. And we just attach the unchanged, unended. Okay. Unchanged, touch down the view. The second one, the view. Image. Okay, so we're only going to put it on the button apparently. All right, well, let's add it and see how it goes. Give it a gesture. I'm going to comment this out. Okay, drag gesture, and then it was on changed. We will do this. On ended, we will do this. Unchanged value. I guess we just want to ignore it. Yeah. Okay, so if this works, when we touch the button, it should it should start moving, and when we come off the button or maybe release, I think it'll stop. Okay, let's try it. I would have been happier to having a button have, onEnter, onLeave kind of thing, or, something. So hopefully I press on the button, it starts moving left, and I release the button and it stays to the center. I don't think it moved anywhere. No, that's not doing what we think it does. Okay. Create an image. Add a gesture. Let's print in there too, just to make sure if we're getting in there. And this one is ended. Now I don't know when this is from. 2020. Well, that's pretty recent. They do keep changing it all the time. Okay. Oh, yeah. The Swift UI only lets you update in the main thread. So I run the basic in a separate thread, but the things that affect the memory or the keyboard get published, and it tells the UI to update it. So they publish and they notify in the main thread. Let me see if I can find that. But yeah, it's a little bit funny. So that's in Poke, I guess. Yeah, so we consciously run this in the main thread so that when we update the screen, the UI gets a chance to get, well, the UI gets notified, and it can do its thing. Okay. But this drag gesture thing I don't think is working. I don't have a good insight why. Maybe let me go back to button. Maybe there's something on there that would tell us. So if I just get back to the constructor, like, can I make one that's just a label? Doesn't look like it. They all take a action. All right, let's Swift UI detect button press. And then we'll stop. Okay, yes, that's what I want to do. He tried the get drag gesture thing. I tried composing. Well, that's certainly more work than I want to do. Okay, if I can't do it, I will let it go. I mean, that first one made it sound like somebody's got an idea that works, but it just looks like more than I want to fight with. No, let's see what good old hacking with Swift does. Okay. No, that's not much help. Okay. Well, I think I'll let it go. I'm probably not updating my to-dos here. Let's see. Make poke handle 530. Okay, that would be that. Yeah, maybe we got to do something like that. I mean, that's kind of what's going on. So when you've pressed that button, it sets that keyboard simulated value, and it basically comes back through every time, as it loops through and reads it again. So it's, pushing the button and releasing sets the keyboard value, and then the basic side polls it. And it's not really an interrupt because it's just kind of in the loop of the basic program. We've got enough delays. Let's see if I can show you those. Okay, so yeah, here's one, delay 30, but we had these loops in the original, and okay, yeah, so they put a little bit of level of delay in as quickly as they're going through. I had a little more in there at one point when we had a main loop, and I just took that out. Okay. To do. We didn't really do that. Let's make buttons detect, press, and release rather than just staying on. Okay, I think that's what we're sort of doing. And I'm about to give up on 0716. Cool. All right. Poke handle 530. Really, I want it to ignore it. Control C. Okay. I think I want to do some more. I want to move refactoring up. So let's see if we can talk about how this looks. I want to do one of these things where you just kind of fuzz your eyes and look at it and like try and understand it from the nesting levels and things like that. But when I do that, this first block 49 through 60 is just sort of like initialization. It gets run once and never again. Then we have a loop, a little bit of stuff, a loop, and then some stuff, then the body. Okay, so in the body we move, and then we place the ship, or else we jump out because we lost. And then if we jumped out, we handle lost and potentially restart. So this loop, nope, this loop If you still have lives remaining, then you get to do it. Okay, so I don't know if I can. I don't think there's a. Can we fold this usefully? Yeah, I would kind of like to. Well, I'd really like to fold this. Can I do that? Almost. Why did you not? Huh. It's just not doing the body I want. Huh. What if I just select it like this? Is that it? Yeah. Okay, it's a little clunky view, but can I do that? No. I guess I have to select the main body of it and do it like this. Okay. Yeah, so I think we can see it from here. We run through the main loop, we run through the asteroids per line. This waves, we're just catching it so we can use it in a printout. And then these pokes, I think we don't really need them. They're not doing anything in our simulation. They weren't doing anything in the. I mean, there were 24 by 24 screens back in the day, and then you could set it up for 32 by 30, or they allocated memory for 32 by 32. But the video driver stuff really didn't do that. You could get a later driver that did, but in our case, this is showing up off screen, and so it's not doing anything. I'm going to keep them. I'll comment them and keep them. Okay. But my point is this use of waves is going to be inside here or out here. It's really a way for us to catch the global variable so we can look at it in Lost. Okay. But we got loop, 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 and there's almost nothing going on in here. I mean, very minimal, just capturing a global variable. All right. And then this body, and then the body can set the lost flag and jump out of main loop and end up here, and then we handle all the stuff. Okay. So I don't know. I don't want this. I don't like this. Well, all right, let's look inside this for a moment. Okay. So if you lost, basically we jumped out of the loop and said, okay, you lost, boom, that's this print stuff, and decrement your lives remaining, restore your level, pause briefly, let you look at the score, pause, and then I don't know why we're poking the ship here. That's just kind of useless, really. And then print this stuff, which mostly clears the screen. Okay, I mean, all good stuff to do once you've lost and you're trying to get back to the top of main loop. Okay, because if lives remaining still has anything on it, you're just going to go back up. It's greater than 0, then you get another shot at it. So, okay, let's look in this one now. All right, now this one, it's basically printing. The printing is part of, well, these two. The print here and the poke effectively generate the new line. Okay. And then we move the ship and check for stuff. But what I don't like, and this stuff has to happen on the inner loop. This stuff just should only, like this part here, should happen on the outside. And so I'm wondering if there's some large restructuring we can do, and I don't know exactly where I'm going here, but Um, let's see. So it's going to, in the end, init, and then loops, and then in there we generate row, read, and move the ship. And lost, we exit all but outermost loop. Yeah, status line on the bottom of the screen. That's certainly possible. Yeah, I mean it's a reasonable thing to do. These two things we could pick. I mean, I think we're poking in. Let's see. I took a picture somewhere. This, yeah, we're not quite poking in the last visible row. So even here, you could put it. You could squeak it in down here in the 24 character screen, or you could move the last row up one, and you get one fewer visible row. But yeah. Okay. Yeah. Lovely. Let's go there. So you can get that. Yeah, you got the stuff down at the bottom. Right. I mean, I think that looks nice. It's certainly nice to have the feedback while you're going. And yeah, well, you could do it at the top, but it's a little different because the basic print, it just prints the line and that's how it moves it up. But I mean, we could overwrite it or something, but yeah, we didn't. All right. So gosh, I don't know. The thing I have in mind, well, one idea is if things were more, well, okay. The problem in a way is this structure, the interesting thing, if I think about polling versus event driven, I'm doing a bunch of stuff and then I do this read that's a polling mechanism and trying to read my keyboard, which I've simulated with buttons. And then I do some stuff. Okay. So the read is happening right in the middle of everything. And because it's polling, and implicitly it's pausing. In the old basics, you didn't have to pause because they were slow enough that you could, you got enough of a pause already. Probably, usually we're more interested in moving more quickly than more slowly. But at any rate, you stop here in the middle and read this thing and poll this thing. You're actively asking some other entity, "Hey, what's your state? What's your state?" And so, in a sense, it's it's wasteful that you're out there asking all the time, because a lot of times it might just say there's nothing going on. And if you imagine a very quick loop, right, it's saying that all the time. What I would like in a way, and I worked out a recipe for this in another context, and maybe we should just try that. But what I think of is like, if I change this to event driven, then what happens instead of a read is there's an event comes in and I have code that responds to it. And so if I take that notion here, an event comes in, it sort of has to start here and say, oh, move the ship, check the lost, and then somehow go through up here to generate row. And then that's sort of the end of that action. Okay. So the polling one, you just keep going until you stop and you poll. The event driven, you sort of grab somewhere. I think of it as if my program's made of strings tied together, and I grab this string in the middle where the reads are and I pick it up. Actually, I almost slice above the read and take that piece and put it at the bottom where it happens naturally from the repetition. So that's the kind of move I'm trying to make on this. And sometimes you can do it without going through the gyrations that the refactoring I have for that will do. And I'm going to have to pull that up and see what we have. Is there a better way? I mean, it's a little funny having the break in the middle here, right? It just sort of says like there's a different structure that could do this. The other way I'm thinking about, and I don't know if it's a better way or not, but it's almost the other way is like I almost want to turn this. I almost want to turn these two loops into kind of an enumeration. And like I want them to generate the list. Okay, 1 1 1 2 1 3 1 4 1 whatever up to 20 plus 5 times level minus 1. Okay, so this is sort of like saying the first level you get 20 stars, 20 rows, the next one 25, and so on. If I had that list, that sequence of pairs for these things, then for each pair I would do an action, this body. What would that do for me? I mean, I don't know. I've been reading stuff. I've been going back and trying to read through some old design stuff, like, I don't know, 1970s era designs. And one of the constructs that they had is the coroutine, which kind of went completely out of favor for a long time. We used subroutines or functions. The coroutine, like you get a bit of it with the yield statement in C sharp. You can define some stuff and just say yield value, yield value, yield value, and when your function gets called, it sort of like jumps to wherever it was last left off, and then runs until the next yield. Okay, and so you end up with these two things. They're kind of quasi parallel, and I kind of think that's what I'm after here, but it's hard for me to be sure because it's like how many functions or subroutines have I written in a moderately long career here? It's like lots and lots. How many coroutines? Well, I probably stumbled around through a couple things that were acting like that. I know there's a package for Swift that is a sort of coroutine. I haven't played with it. I don't know. I looked briefly and it looked like, oh, there's some weird limitations. It's not native. It's built up. You can simulate them, kind of like I said, you just kind of keep track of where did you, almost like a little state machine. How far did you get? Where should I jump to next? And as things come in, as it gets its turn, it can jump. But let's say we had some sort of stream that delivered these pairs, asteroids per line and this number, which we almost don't even look at. That's the weird thing. I mean, if you had that number, you would execute once for the first number. Where's asteroids per line used? That's down here. When you're actually poking out the random stars, you're using the asteroids per line, the main loop, or what I called main loop, I guess before lives remaining was a thing. Oh dear. Okay. I mean, it's kind of. So what I'm proposing is, what if, let's see, so here's an alternative. Really just an idea. A stream that generates wave pairs, wave number, and I'll just call it rows. It doesn't have a name because we don't really reference this variable, but I'm going to call it rows. Okay, now if I had that stream, then you would basically do something. You would read a value. Well, this is in a loop. Loop, read a value, generate stars, move ship. Okay, and the loop is not well, the loop is going to be controlled by have I lost. Okay, I want the loop to be like while not lost, then maybe here. I don't know. I'm changing what's going on a little bit. Okay, but you would read from this stream. Generate the stars, move the ship, and then, well, check lost and move the ship are kind of the same bit of stuff. Now, I don't know if we can... Yeah, it's interesting. I mean, we can almost... I almost wonder if move ship could come up here. It's, let's say, place ship. Okay, so this one is take apart the loop starting at 76, turn it into a stream of pairs, and then run through that stream doing everything, but stop as soon as somebody says you lost. Okay. Another alternative. My keyboard is going. Can you tell? So the other alternative I have is basically it's this medium-sized refactoring turn pulled into event-driven. Okay. Now you could probably do both. It would probably be easier to do the second one once the first one was done. But let's see. All right, so I think we'll do some assessment on that. And I think let's just take a break. We've gone a little bit. Take a 2-minute break. We'll come back and look at what would be involved in the event-driven conversion and see where we go from there. All right, see you in 2 or 3. All right, welcome back. Let's see. Similar thing in Lua called coroutines. Yeah, so they're definitely picking up that old idea. I mean, I have my Knuth Volume 1. Let's see. And the original, I think, was 69, 60, 68. Okay. So, you know, they're back kind of before things all settled in, you know. Let's see. I'm pretty sure coroutines are in here. Yeah. So he spends a good little bit of a chapter talking about them, you know, and there's definitely routines, you know, there's definitely structures that make it a nice thing. The thing I've seen it described as is like in subroutines, you got the parent routine and the called routine, and it's a hierarchical relationship. You know, the parent is in charge, calls the child. With coroutines, you have these two things, and they're both sort of working through their own process, and yet you can call the other one to get back and forth. So I think it's a useful thing in games where you got these sort of little cooperative things going on. But another one where they used to use it was in compilers, like you have to read the next character. Well, there's mechanics that have to go on to get ready to read the character after that, or read the next token. And again, there's mechanics that go on. So it's kind of nice if you can hand control over, and then when you get it back, you pick up where you left off, and when you're good and ready to spit out another character, you do it. Okay. Yeah, nice. All right, let me get to preview. So I started writing a book about 4 years ago. Had this horrible accident, and then trying to figure out if it made sense as a book or not. But I've got a chapter in there on console app to event driven, or polled to event driven. Okay. Yeah, this is a major change. All right. So, okay. Isolate the output. Identify pesky code. Okay. Um, right. So pesky code, our handle move code is pesky because it calls the read in there. Then it makes a few decisions, and the stuff that's not is better. Okay. So we can't do this indirectly. Remove recursion, inline the pesky code until the reads are at the top level. Okay, so we have read main AB. I guess B calls read and calls C and D, I guess. So inline A. Now we have B calling read and C and D. Inline B. So we're just inlining until we get this read right up there at the top. Okay. So the main routine has all the reads and can also call regular code. You can refactor regular code away from the main routine. Yeah, just leave the reads up there. Okay. Make all reads use the same buffer for their input line. Okay, I mean, we're only reading from one place, so it's not hard for us. Extract the read call into a one-line method that tracks case where the handler should resume. Okay. This one, well, this is kind of like our go-tos in a way. It's like, do read. When you read, I want you to go to this target afterwards. And then we're going to basically pull this apart and make targets out of the code. Okay. So, this is a little bit of an awkward thing. I don't know. This may be more steps than we want to do. Okay, so begin and end. Yep. This is like, I don't know, like awk code. Yeah, I don't know if this is just yeah, we're turning it back into a big go-to mess. I don't know. Is that manageable? Okay. Yeah, I remember working this through on a console version of something. Yeah, that's a pretty small example. I don't know. That's a pretty big change. But one thing it's doing, okay, handle move used to have all this lost stuff in there. We pulled it up to the main loop, then we pulled it out of the main loop because it's only happening after you exit. Okay. But one thing that is going on here, like this decision making, the peak, this is the read. I mean, these three lines, these three lines force the read. And then this stuff is, this is what we get back, and we make a decision about what to do. You could make an argument to make this just be a read method and pull these things up. And I think maybe that's worth doing. All right, so what we're going to do, we're going to make this thing return an integer, which is the key matrix. Okay, and okay, so nobody's using it, so the call site might be a little funky. Yeah, let's let key matrix equal that. Okay, and we'll run this. There should be no harm because nobody's looking at key matrix after this thing. Okay, well that's thinking. Let me change the to do because we're again doing something different. So we're going to separate key reading from ship moving. Okay. Go. Oh, I didn't change that back. Hang on. All right. That's what we remember. Oops. All right. Well, it seems to be okay. Okay. So swarm here. So this handle move, I'm going to pull these things up. If key matrix is there, and I return it, I'm not changing it in these two lines, then I should be able to move these two lines up wherever handle move is. Okay. And then I don't need these two lines here. Okay, so I could have inlined this and then retrieved it back out. I'm kind of taking a shortcut because Xcode doesn't really inline, so it's got to do it manually anyway. All right, so I've made this. So this is just let's rename this. This is now just read keyboard. Okay. And again, I don't think we've changed anything. Okay, yeah, still looks like it's going. Okay, let's commit this. All right, now can I do something good here? So levels. Okay, if you get through all this, 10 rows, 10 stars, you've gone through hundreds of lines, you haven't lost, you just come back around, level increases, but you go back around on the main loop. Okay. So I guess you could restart your stream. You wouldn't care. I don't have a. Trying to think how I can generate this thing. I really kind of want a lazy stream. Can I do that? Well, it's certainly finite because it's at most 10 times. Oh, no, it's not finite. Well, no, it's finite. On any given level, it's finite, but your level can keep going, theoretically, if you're really good. Pinball wizard good, you know. But this loop, given a level, I should be able to make something. I don't know. Okay, let's look this up. Create lazy stream in Swift. So, basically we make an iterator. We make our struct be a sequence. We give it an iterator. I don't know how it knows to implicitly. Oh, right here. Uses the iterator. Okay. Any sequence has a type for the closure base that you can implement sequences very quickly. Okay, little markup. Return any sequence. Returns an iterator for model. Well, I don't know. Maybe that's another step. Like, what if I had an array that had these pairs, I and wave, whatever we call it. I guess I is wave depth or intensity or something. Okay. Let's try and create that. That's certainly a doable thing. Creating it in advance is a little goofy, but let's just get it going here. Okay, so let var values equals nothing. And then I'm just going to put the loops. Okay. Yes. Well, this is int. Okay. So I don't know how experimental to say this is, but I'm going to exit one loop, exit the next loop. Okay, what I'm appending is a pair, which is asteroids per line, and I'll call it intensity. City. All right. Value of tuple has no member append. Value of tuple type. Oh. Okay. So at this point in the loop, I've got an array that spits out the same values as these things. Okay, what I don't have. Okay, so, dear. This is definitely a non-standard refactoring, and we're doing it manually with only manual tests. Ugh. All right, so I've got this loop. I've got all the values that are going to get spit out by either one of these for a given level. And I want to execute the body. I can't extract it into a method, so I'm just going to duplicate it. Okay. So up here, I want to go for asteroids per line and intensity in values. Waves equals asteroids per line. Paste all the old stuff. And we'll call this new loop for now. I'll put a label on it. New loop. Okay. Mutable value of intensity was never referenced. Okay. We don't care about intensity. All right. Now, if that loop works, I don't need this one. But it's a definite question as to whether that loop will work. All right, let's run. Now, it may be a little slower, chunkier doing that. We'll just have to see. Not slower that I can see, but it appears to be working. So that's something. Randomly moving around sometimes works. Okay. That's probably my best score, isn't it? Okay. Cool. All right. So that's a refactoring I've not done very many times. Maybe 2 or 3 times ever. So what it's doing is it's splitting nested loops that don't have a lot going on up top. Okay, nested loops that only do their work in the body, basically. In this case, the only thing happening was waves, and we faked our way around that. Okay, so you split it, so you generate the values of the loop, and then work your way through them. That's okay. That's interesting to me. Yeah, let's accept it. Whoops. Okay, so and I call this okay, we did this one. To me, this is something like split loop into content generation and use. Maybe split loop content generation and use. Generation. Value generation. Yeah. Okay. That's not your everyday refactoring. And I'm not sure I've completely characterized what you have to do, but you definitely can't have Well, if you have stuff that's only supposed to happen between the two loops, say, then you got a problem because you're going to have to, if you repeat it here, it's happening every time. So you'd have to repeat it here and only do it if the value, if the value is 1, you could do this. In this case, the waves, I don't think it matters. All right, where does it get used? Down here. Okay, so we're just kind of capturing that. Given that we only print it when we have lost, we could move it into this lost. Well, we could capture it here only, but that's okay. And like Foxcode 64's version, he puts that wave out there all the time. So in that case, it is part of the loop to update the waves. Okay. And if updating the waves meant poking the same bytes onto the screen, even though you're doing it more often because you're doing it every time through, maybe it's okay. But I think I can take new loop out now because this is a 1 level deep loop. All right, I can just break, I think. Yeah. Okay. So you had to have the label in the other case because you were breaking out of the outer loop. Now we folded all the loops into one loop. All right. Let's run this. And to trigger that break, we have to lose. So let's crash right away. Oh, I'm supposed to crash. Okay. Anyway. Yeah, so that's doing its job. All right. Let's commit this. Split loop value generation from processing. Remove label on break. Okay. What else can we do? Okay, so that was this one. I'm not doing it while not lost, so I could. So what it's making me want to do is a change that I should be able to poke my ship earlier. And all right. The deal is we go through this with ship is set, but we never poke it up until we've already checked the keyboard once. But if you haven't moved, the ship is going to end up in that middle column or wherever it starts. I almost think you could get by with it. If you're at the top of the loop, you are not dead. Okay. You may be ready to move. All right. I think I'm going to try this. Let's take this and move it up here. Whew, how's that going to work? Before you did the print, print is what shifts everything up a line. So do I need to be after the print? Let's try this. It's double poking, but it's poking something on the first iteration after the print. I'm trying to get the outputs and the closer together. Ooh. Interesting. Okay, that is not equivalent. What if I move it up? Okay, I think that's okay. So before you came through and at the end you poked and then you came back up here and printed. So I guess we're just saying the first one gets out free. I don't think we did a poke up here. Yeah, if we had been doing a poke up here, I could just say that's the way it is. All right. Let's try taking this one out. Okay, so if you are a space, you're going to go back around to the top of the loop and poke it where you wanted to put it. That seems okay. All right, let's run. Supposedly simple things is difficult. Yeah, I have an old breakout program, TM, I guess, right? Same thing, and that one's not quite as ugly as this. This has that break is a little awkward. All right, let's go. Now hitting this moves it to the right one. That's a little weird. Okay, the boom is right beneath the V, so I think we're okay. It may be doing something funny, but now we can flip the conditional. If it's not a space, then we've definitely lost. We should jump out of here. Okay. Now that makes me want to pull this back in, honestly. Can I extract this as a method? Let's see if that does what that does. Okay, so this is handle loss. Oh, I couldn't get those ampersands to work before for nothing. Where's that getting put up here? Oh, in out was not going to work for me. Okay, that's why. I'm going to pull this method down. I like to read top down usually. Although I had one the other day where I really did want to read bottom up. I wanted to set some conditions so you knew these things were the standard helpers and then go into it. Okay. It's got some in outs. We'll live with that. But I think what's interesting. All right, now maybe this can come back in. So we know lost is true. It's going to break and come out here. But I think I can pull this back in. Comment this out. Okay. The only reason this lost flag is here is so that we know to handle it on the way out. All right. So let's see if this works. I guess working will be we come in, we crash, we should come out and start again with another life. Okay, and notice the level increases after a crash, so it's starting out harder. All right, let's see how this is. Just need to crash. All right. We'll crash again. Make sure after that third crash we terminate. Okay, 3 runs and done. All right. Okay, so that is handled. This variable lost now is not being used for anything useful. So we're going to take it out of the picture. Handle loss, take out this, and take out the setter on it. Okay. I think just running this once should be enough to prove it out a little bit. Let it crash. Okay. All right. So what we did, we moved loss handling into a subroutine, called it from the main loop. Should probably call it a function in Swift, huh? It was a basic subroutine. All right. Let's see now. What else can we improve there? Well, I almost want to pull this into a routine, a method. If crashed, again, I'm going to pull it down. Okay, crashed. And I want to pass ship in. Okay, is ship... I'm pretty sure it's an int. Everything is. Ship int. Okay. So that to me... So I'm trying to get this thing more readable at this level and saying, okay, a bunch of stuff happens. If the ship crashed, handle the loss. Okay, and break out of this loop, and then we'll go into the main loop. Now, this one... To me, this is like generate asteroids. Okay. And again, that's... I'm just trying to get the text of it making sense. Well, it kind of happens up here. All right. Waves. Again, I think because this is now inside the loop, we can use asteroids per line. And we don't have to update waves any. Okay. This thing looks pretty good. I just didn't know about doing the double loop with it. All right. Jump far left. Jump one over. Jump one over. Oh, should have gone back. All right. That seems okay, though. All right. So I'm just trying for this readability. That was generate asteroids. Well, let's see what we got coming in. Generate asteroids. Crashed. Okay. All right. Well, again, we've gone for a while. I think let's take a 2-minute break, maybe 3, and we'll come back and clean up a little bit more. All right. See you in a couple minutes. Welcome back. All right. Let's see. Okay, waves is never used. We can kill that did variable. All right. I will trust the compiler on this one. Oops, didn't save. Okay, what do we want to do? Well, what's weird now? I guess what I want to do is move this more to being a Swift kind of game and less of a basic game. Okay, I don't know how much I want to go into that, but that's where we're going for now. So one thing is Poke 530 is totally a basic related thing and not relevant to us at this point. So I don't see any reason to keep this around. Let's kill that. Let's look for any uses of 530. And this one. Okay. Then this read keyboard, I think we can just say return peak. That's also clearly a basic thing, but we'll get there. Okay, so okay, I guess I was going to run tests, but we don't even have a keyboard, so I don't think we have to worry about Control C being hit. And if you want to stop, you just throw it away, and that's the way it goes. Okay. So and we inline keyboard routine. Alrighty. Well, this stuff sticks out. The ship positions. I don't know. That also. These 5.3, 5.2.0 stuff, right? Okay, what I would like to do is I would like to make my ship. I want to make it, how far off are you from 5.3.509 to 5.30? Okay, so I guess what I want to do Well, if you were 53510, you would be 0, 1. So I guess that's 11. Okay. Let's say, let's introduce a new variable. (53509). Okay, so I'm saying 53509 is the position of the ship on the far left side. Okay, based on this 53509 right there. Okay, so that would be this first pink cell. And I want to say the ship. Yeah, that's a true let because we're not going to change it. All right. This is ship base plus 11. Okay. And then this is 0. If it's greater than 0, let's see how I have to do this. Wherever I poke ship, it has to be ship base plus ship. Okay, any references to ship are now ship base plus. Okay, so a reference to ship here is really, we subtract ship base, and that's what ship is. Okay, so if we subtract ship base, it's 0, and 53530 is 31. Okay, we can be equal to 31. So this was 53509 to 53533, right? Let's diff 53533. Where are you? Yeah, 53530. Well, interesting. We weren't going to hit the last few columns. 9. Let's run this thing, and let's go to the far right. Okay, I guess that's as far right as you can go. I think our star generation, I'm as far right as you can go. So our star generation is actually generating a wider spread of stars. Okay, because this is 21, right? 30 minus 09 is 21. Okay, so I'm allowed to be 53509. I'm allowed to be 53531. So I guess my range is really 22. Or 21 here, yeah. This 30 minus 9 is 21. Yeah. And this one's only 23, but it's 0 to 23. Where does that generate? 23 times that, so it can't be 1, so it's 0 to 22. Interesting. Yeah, I mean those numbers are all coming right from the old listing. So yeah, the boundaries were never right as far as I can tell. Random never returns 1.0, so you can be just under 23. I don't think that this is not rounding, this is truncating, so You can be 22.999. You'll become 22. So the range is 0 to 22, which is 23 values. So, on a screen of 24. So yeah. All right. So, well, let's refactor for the moment, and then we'll then we'll decide what we want to do. Okay. So I think this. Let's see. Let's make sure if anybody else is referencing ship. Okay. Oh, I'm still in this mode. All right. There's ship. If crashed, ship. Okay, this has to be ship base plus. No, I'm gonna have to make that global. Well, it's static anyway, so. Ship base 53509. Base plus ship. Okay, let's find. These all have to be ship base plus. Okay. This seems a little silly, but okay. Well, I'm sure it was a bug. I mean, you had 24 characters visible. Like, why wouldn't you use them? And especially, why wouldn't you let your joystick go over there? Or your move. Okay, let's get back around to ship, base, ship, base. All right, let's run this. I guess we need to crash, and we need to move the ship left and right. Oh, something's wrong. 107027. Okay. Yeah, there's probably more quirks kicking around. Let's see. I messed it up. Sure enough. Okay, let's revert that. I think I want to make sure I'm doing this correctly. Well, why am I doing this? Because I think when we get this thing, the more we translate it, we're going to just want to know, we're not going to want to know the basic value, the basic offset stuff. Okay, so let's see. We got asteroid base. We're going to make ship base equals 53509. Double check. 53509. Okay. This is ship base plus 11. No, 21. No, it's just 11. It's 53510. 53520. 20 minus 9 is 11. Okay. I think this should be correct. Like, I haven't messed it up so far. And if it starts in a funny place, I guess we would say it's weird. That looked like it was right. Boom. Okay. Let's find anything here. Okay, we think this is the same as ship base. 53509, so this is ship base plus 21. Let's try that. I guess moving left and moving right should be as expected. Let's go. Okay. Boom. Cool. All right. Five 53509. Okay. Now, can I start subtracting ship base from some things? Okay. So, how can I do this? I would like to subtract it there. I mean, one way would be introduce a new variable, and then it's probably more likely to be right. But I'm saying ship. Let's see, what else can I change here? Anything? If I always reduce ship by ship base, then when I do a poke, I gotta deal with it. Okay, ship base plus ship. So I'm going to take ship base away from ship. Okay, let's find poke of ship. All right. You know, I might have missed the peak last time. Oh, might have missed that one too. Peak of ship base plus ship. Now ship, I took away ship base, so it's that much less. And it's still plus or minus 1. Okay, let's try this. I think when we do the breakout one, we're going to, I'm going to put some acceptance tests in. There's just too much of manual running that makes me think I could have missed something. Okay. Oh boy. We're doing this for asteroid base. Okay. What else is unbearable in our main code? The 24, that's sort of a... Yeah, I mean... It's really a clear screen. This stuff's all kind of one-based, but that's not unbearable. Okay. Well, this stuff is crazy, the key matrix. So I'm hiding that down here. This is a little bit... I mean, we could make it do... We could make it return a character, or yeah, maybe make it return a character. Let's see. So let's do this key matrix and see. Where's our read? Yeah. Yeah, I do think I'm mixing up the logic a bit. Equals 0. So some of these things, it's like, are you, is the voltage always applied, and when it's missing, that's significant? I think that's the case here. All right, so I'm going to return a character, and I think this was 8. Key matrix and 8 equals 0, then the character is n. Where'd you go? There we go. Otherwise, the character is blank. Okay, so let's make this happen. Okay, let... Okay, there's a move. If we make a move, let's see if this makes sense. Something is funny. Let's... Let me run it again. It looked like it started out going left even though I hadn't hit anything yet. Oh, we probably don't initialize something somewhere. Keyword simulated now equals 0. All right, I've messed it up again. Let's revert. Okay, yeah, something. All right. If keyboard matrix, what do they set to? Let's see. I may be setting these things wrong for what this logic is. Okay, so we're poking 255. I gotta assume poking 255 says look in all rows. Because 255 is all bits set. But if matrix and 16 is 0, so if 16 is 0, I think that means they're saying there's something hit in this column. See, I would have expected them to set 4 and then look for this specifically. But I think I probably mentioned before, the way you attach a joystick in these old things, in this old one, they basically told you to connect the wires. I think you basically connected C4 and C3. And so I think if your joystick was maybe moved left, I don't know, maybe you had to connect more of them, but I think you had 4 position switches, one for each direction, and you could get 2 at the same time. So if you did diagonal, I don't think it was just the 4 directions, but it may be that like anything in this column says, oh, this switch is on the joystick. So and coincidentally, or maybe we picked it because these 2 letters are adjacent on the keyboard too. But if 16 equals 0, that says 16 is not on. So that would sort of imply it would normally be on. Oh, and so a 0, maybe our default should be 255. Up here, I don't know, this is getting, I almost think this should be the case. And let's see if that breaks anything, but I think the way I'm reading this, where it equals 0, that means that column is off, and which means by default they expect it to be on, I guess. And in a sense, no, does that make sense? No, there's like negative logic in there somewhere. It looks okay. It's moving okay. Okay. Now let me do that change again. Up here. Well, I'll put the logic in here for now. Let character equals space. If key matrix in 16 was 0. Oh, I took out the equal zeros maybe. Then character equals B. So he's var. And if this no harm in that. Now key matrix and this equals 0, I think it's going to be the same as character equals B. And this one's going to be the same as character equals N. All right, let's. My nothing key seems to be messed up. Okay, what's going on? Let me check my button over here. I gotta be consistent. I think this is backwards. I think this is 255. I don't know about these. I think these may be backwards as well. Lovely logic. But if this column is 0, definitely seems like the switch is turning off the column, which really does seem weird to me. No. The center one is making it go left. Sorry, making it go right. The left goes left. Okay, go again. Center. Center's doing nothing. Left is working. Right is working. Okay. All right. I'm going to revert again. But, well, no, my theory was these are really knots. Doing some bit arithmetic here. Well, this is not 0 if you want to be. All right, well, we'll see what this does. I'll probably end up reverting it again if it's not working right away. And I'm not getting any lefting on this. Okay. Anyway, my schedule's pretty full during the week these days, so I think I'm going to try for Friday afternoon like I did today, and then Sunday afternoon, same time, 1 to 3 p.m. Eastern. So we'll see how that goes. And thanks for joining me today. Hope to catch you again in the future. I guess I got to make a decision. One thing I got to do for sure is I want to pull out the basic support into its own little library and use that in the next retro basic project I do. And I may or may not push this thing to being a more of a full Swift UI thing. I don't know. I'm not charmed enough. I think I'll just focus on the basic next time and go from there. So again, take care. Bye-bye.